Air pressure. We're going to start off by looking at properties of air. It may seem like our atmosphere does not have any mass, but the air in our atmosphere consists of atoms and molecules which have mass. Because air has mass, it also has a number of other properties, including density and pressure. Density. The amount of mass in a given volume of air is its density. We have calculated density before. Recall that calculating density is done by dividing mass by volume. Density equals mass over volume. If there are more molecules in a given volume, then the density is greater. So looking at these two Coke cans, obviously the density of regular Coke is greater than the density of Diet Coke. If there are fewer molecules in a given volume, then the density is less. Pressure. The atmosphere is heavy. The atmosphere's weight exerts force on surfaces like the ground and you. The force pushing on an area or surface is called pressure. We're going to learn a great deal about pressure and how pressure impacts our weather in the next week or so. Air pressure is the resulting of the weight of a column of air pushing on an area. A column of air that extends above you is about the same weight as a school bus. So why aren't you crushed by the air above you? It's because the molecules of air push in all directions. The air pushing down on you is balanced by the air pushing up from below you. What instruments measure air pressure? A barometer is an instrument that's used to measure air pressure, and we're going to talk specifically about two different types. The two common kinds of barometers are mercury barometers and aneroid barometers. The mercury barometer is on the left here, aneroid barometer is on the right. Mercury barometers. A mercury barometer consists of a long glass tube that's closed at one end and open at the other. The open end of the tube rests in a dish of mercury. The closed end of the tube is almost a vacuum, so the space above the mercury contains very little air. And the air pressing down on the surface of the mercury in the dish is equal to the pressure exerted by the weight of the column of air of mercury in the tube. So when the air pressure increases, it presses down more on the surface of the mercury. Greater air pressure forces the column of mercury higher. So the level of the mercury in the tube shows you the pressure of the air for that day. So reading a mercury barometer, what would a low pressure air system look like in comparison to a high pressure air system? As the air pressure drops, the mercury in the tube falls and the mercury in the red dish rises for a low pressure day. In a high pressure day, there's going to be a greater amount of pressure forced on the mercury. The mercury is going to rise higher in the tube, causing it to look as if there is a larger amount of mercury within the tube. Aneroid barometers. Most barometers are aneroid barometers. Aneroid means without liquid. It is a barometer that has an airtight metal chamber. The metal chamber is sensitive to changes in air pressure. When air pressure increases, the thin walls of the chamber are pushed in, and when the pressure drops, the walls bulge out. The chamber is connected to a dial by a series of springs and levers. As the shape of the chamber changes, the needle on the dial moves, which gives the overall pressure for the day. Units of air pressure. So if you've ever watched a weather or the weather on television, you've probably heard many different measurements or measurement units used for air pressure. Most weather reports use inches of mercury. The National Weather Service indicates air pressure in millibars. So you may have heard the term millibars before when a weatherman's talking about low and high pressure systems moving in. 1 inch of mercury is about 3.86 millibars. So 30 inches of mercury is equal to about 1016 millibars. Just some simple math there in order to convert from millibars into inches of mercury. How does altitude affect air pressure and density? As you hike higher and higher into a mountain, you'll notice a number of changes. First, you'll notice that the temperature drops the higher up you go. More specifically, it falls 3 degrees per 1,000 feet. We call this the lapse rate. Second, the higher you go, the less air pressure there is. Altitude or elevation is the distance above sea level. Air pressure decreases as altitude increases. As air pressure decreases, so does density. This is part of the reason why if you are traveling up a really large hill in a vehicle, or maybe you've flown in an airplane before, on landing or on takeoff, your ears tend to pop. It's because your body regulates that pressure difference between the altitude. So as you go up, your body has to let out some pressure. As you come back down, as the pressure increases and you're landing, you have to add air pressure to your body. If that doesn't occur, then the atmosphere puts a great deal of pressure on you and on your body. Altitude affects air pressure. Air at sea level has the weight of all the air sitting on top of it. Air near the top of the atmosphere has less weight pressing on it, and thus it has a lower air pressure. Altitude also affects density. As you go up through the atmosphere, the density of the air decreases. This means the gas molecules that make up the atmosphere are farther apart at high altitudes than they are at sea level. So if you were near the top of a tall mountain and tried to run, you would quickly run out of breath. Same thing happens with Dorito bags or chip bags. When they are packaged at or near sea level, the package is kind of crumply. There's really not much, you can't really see much air in them. If you take that same bag of chips into a higher altitude, it tends to expand. It looks almost like somebody put an air nozzle in it and pumped it full of air. It's because the air pressure decreased outside of the bag, so the air pressure that was inside the bag, which remains constant, appears to have a greater pressure. The reason that you quickly run out of breath is because oxygen molecules are farther apart the higher up you go in the atmosphere. As you go higher up and don't get as many oxygen molecules, your body is going to think that it is running out of breath. This causes you to become short of breath easily, and if you continue to not be supplied with the adequate amount of oxygen, you can get what is called altitude sickness, where basically your body's been deprived of oxygen.